So give me your hand, help me to the plan. No, I don't ever wanna see you cry. Oh yeah, no more tears. Oh yeah, no more tears. Take that chance, we'll be fine. No, I don't ever wanna see you cry. Oh yeah, no more tears. Oh never really saw you coming until you turned me around. Used to think I was nothing, but look at this love we found. So give me your hand, help me to the plan. No, I don't ever wanna see you cry. Oh yeah, no more tears. Oh yeah, no more tears. Take that chance, we'll be fine. No, I don't ever wanna see you cry. Oh yeah, no more tears. Oh yeah.
Hello, everyone. I hope you're having a good day. Today it's day three for the part three of the antivirus evasion techniques. In the previous sessions, we saw the first part and the second part. Also, I'm sorry for the delay. I was trying to set up Twitch, but it did not work, so we are only streaming on YouTube. I don't know if anyone's got a problem. If you do, comment, please. Although there is no one watching, but that's fine. We are here to learn. If you don't wanna stick around, that's fine. It also helps me to try to explain things. So, yeah, in the first parts, we did the malware C++ and the malware Vir2. And I told you had a problem with the GCC. I fixed that problem, and we can officially do this and then execute it. And boom, it shows our calculator. This is the payload for the calculator, and we can finally see it. That was the part one. And in the part two, did obfuscation, meaning we changed the code so it will hide the data, but we also had some problems, so I didn't solve them on my own because I forgot about them, to be honest. Let's see what we can do. A dioxygen comment, what does that mean? Dioxygen comment. How to put comments in your code. Okay, quick fix. Generate comment. Did it do anything? No, it did not do anything. If I do, does it fix it? No, of course it does not fix it. What? How is the comment in C++? Is it not like that? Forgot. Comment C++. Okay, it's like Python. You can do it like this. Anything? Will this fix it? No. Okay, so that's not the issue. What is the issue? Let's do them one at a time. First one, an empty initializer is invalid for an array with unspecified bound. Okay, so essentially does not have a bound. Let's see what he does. Let's see it in the in here. If we do the GCC, I think he does it the exact same way, even though we followed his steps. So um, we will probably be fine just like that, but I will check it anyways. How did you compile it? He did this. Okay, so let's try doing the same thing. You go here, you go here. Terminal GCC, the malware, the v2. And what did he do? What did he do? Minus oh malware v2.exe minus s minus f function section minus f data sections minus w no right. I can just copy and paste it. Why am I making it difficult for myself? Okay, paste. Oh, yeah. Could not find. Yeah, because we're not in Linux. Manage cyclib. Do you mean manage cyclib GCC? Sure. What's the problem? Invalid conversion? Okay, so it just tells me the error. It says it's an unsigned chart, is it? Yeah, it's an And science art should it not be? I think it should be. And science art, yeah. Okay, let's let me just try to copy and paste however it is. I will not change anything. See if there's an error. Yeah, still there are the errors. Why are there errors? Why does she not have the errors? Okay, let's try to do to execute the exploration.py. It just return Python. What does that mean? Let's delete this. Try again. Okay, let's copy and paste his code, but let's not forget to change some things. So firstly, this is gonna be malware v2, and this is gonna be malware v2. And is there anything else? Virtual log? No, 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 no. Okay. Now that we can do it, let's go to virus total and let's upload ourselves this file. I can't do it, so I have to go here, testing, and this. Confirm. Let's see the flags. It's probably gonna be in the 50s. What? There is a virtual look. So yeah, that's the first one. Why is there only 35 and to him it's way more? Okay, I don't know, but if it works, I guess. And I think that's it. Let's try executing again. Acceleration. Python. Why does it print Python? This should be correct. Let me try Python only. What? Python declaration? Python. Why does it only return Python? It should actually change it. Why, why is that happening? Let's save it again. No. Okay. Why? Let's print hi here. No. That's really weird. Is there a particular reason why this is happening? Let's try this. It just returns Python. Interesting. Don't really understand why. It should never actually do that. Okay. Return. Okay. Python file execution returns the word Python. Okay. What? Python 3. Okay, let's see my Python. What? Let's download it, I guess. Don't know why that's happening, but if since it's happening, oh, I might not have it installed. That's probably why. Let's change this MD if I can actually just do Python. Yeah, I cannot do it. Yeah, that's probably the reason. Okay, let's now close this. Let's search MD and let's write Python 3. Yeah, okay, now it works. Let's close this up, open it up again. What? Okay. Uh, Python 3, acceleration, what about now? Okay, yeah, it's better. Successfully compiled. Uh, yeah, and here it is. Where is the virtual? Oh, okay. This is our payload for the virtual unlock. Okay, great. If we in, if instead of close this, let's replace this with this. Will this change anything? There is an executable also. Why is that? Evil encrypt. Uh, that's why. Okay, let's try again. It did successfully compile, but again, no evil.exe executable. Why is that? It cannot find this. Let's close, let's delete this. Yeah, let's try again. Clear, and we will see where the problem is. Python 3 acceleration. There is this. If I try to gist it, oh, no, I can't. Due to the errors. Okay. So essentially, it can compile it, but it can't. It creates the file, or it opens it and writes the data. It cannot compile it because if it did compile it, we would actually have an executable called evil.exe. And it prints the last message successful, so we know that this actually worked, but it gave us this error. It says the system is not in a position to track the given uh, track of the disk. Why is that? Okay, if I remove this because we're not in a Linux, will it change a thing? Note here and here. Okay, yeah, it did change it because before it did have this problem, but now we get just the error of the compilation. Compilation, where we compile it. It actually has the exact same problem, but I don't know why is there a problem like that. What's the quick fix? Disable. Fine. Wait, that was it? Really? No, we still did get the errors. Probably, oh, is there an error here? Still there is an error here. Manage of permissive. Should we add it? Let's just try this. Permissive. If we do that, will something change? No, we do still get 3 errors. But we do get the executable. Okay, let's try to execute it. Will we still get the calculator? No? We should get the calculator. Okay, let's open it with pbear. I will open both of them. I will start with the first one. Load p's here. Let's go with the A first. And here we can see a couple of things. Firstly, we see here the hexadecimal values. We can see the DOS shader. This is like P stuff. This is it's they are predetermined. It begins with the DOS shader, then the DOS stub. Then there are the signature, the file reader, the header, and then there are the section headers, and then there follows the actual text, data, and whatever is in the file. Here we can see some of the not binary, the assembly code. For example, here it pushes R9 as a variable, pushes some variable. I think this is ARM. This is probably ARM architecture. It yeah, these source are 9 to R9, so this always gives us 0. Why does it give us, if anyone's asked, it's actually really simple. Black, let's go to Blackboard Online. Let it load. While it loads, we will continue. Sometimes, if you see yeah, you see the MZ. The MZ is the magic number. This shows that it's an executable. I think. What is the magic number in P? The magic number in P, portable executable, yeah, represent yeah, okay. That DOS shader. Okay, so it's like a signature for that file is DOS compatible. And you will usually see that, yeah, cannot be run in DOS mode. This is the most usual text. In here, we can also see the strings, some of the strings that are inside, like main file, the address, virtual protect. I don't know why there are some of these. It's probably from the compilation. And this is the most usual text that it begins. Then we can see also the imports, like libraries that are imported. For example, in the kernel 32, we can see some of them, like virtual alloc, protect, wait for single instance, and that's like some examples. Sleep as well. We can see some resources like data stamps, some more basic offsets, some exceptions, but the most important ones, in my opinion, are the disarm. If you want to actually read the binary, the assembly, the strings, which will show you generally about the strings. It says it's a calculator, okay. The imports, in my opinion, disarm strings and imports are the most important things to see. Um, Let's now, we saw that in the kernel 32 there is the virtual alloc. If we do the same thing for the evil, we should not see that. Is there the same thing? Yeah, MZ cannot be run touch mode. Kernel 32, we can see it, but oh, because we are still in the a.exe. We want the evil.exe and the imports in the kernel. We should not, yeah, it should be here. There is no virtual alloc. So we know it works. Are there any strings, important strings? Address, no, same thing. Okay. If we did execute it, we should see the calculator, but we don't. It, why does it not show it to us? It should do the same thing. I don't know. I guess. Well, it's whatever. Well, you get a general idea, I think. Um, is there anyone in? Probably not, but let's just check anyways. No, there is no one inside. Expected, I just checked anyways. Um, okay, what I said before was the XOR, the R9 with R9. We will always get 0 instead of 1 because we actually do compare the same bytes together. So if this is like 0, 0, 1, 0, 1, 1, we XOR it with itself. So we essentially get the same bytes. So it will always compare the same bytes. So it's gonna be always 1, 1, which is 0, or 0, 0, which is gonna be 1, 0 again. So it will always give a 0, the XORation of the same number. Let's see it as well in the CMD. I think I can do the strings command. Yeah, I can probably do it. So let's go to the downloads, or is it in the CD desktop, CD testing, and strings evil.exe. We do get a lot of them. Can I grep in here? Or is there no grep? Yeah, grep is not recognized. Recognized. Okay, grep in Windows. Is there something? Find str. Let's try that. Find str. Great. Okay. So we see that there is no virtual unlock, and if we do the exact same thing to the A, we also see the allocation. So we see that it changes a lot. That's it for the first two parts. So let's now move on to the third part. It took like a long while. It took me like 30 minutes, but that's fine. Doesn't matter as long as we understand everything. Okay, so hello to you again. This is the third part. In this part, we will try to implement some techniques used by malicious. Oh, we never actually uploaded to Aristotle. Let's try it. It's a quick thingy. Sorry for the delay again. I think before we did 34, I think we did have 34 flags. Let's see how many we do have now. If it's below 30, we call it a W. Yeah, it's 28, so there are less. So it's better. And as he said, if we actually remove more, like the virtual protect, the single object, we can actually lower it even more. So what's next? Let's take a look. Okay. Yeah, this is without encryption. This is changed. Yeah, he has the payload inside the main function. Okay, let's create a new malware ver3 C++. Include all these. Come on, nice. And let's explain them again. Classic libraries. Then in the main function, this is also traditional, the int argument c and argv, which is an array. I don't know. I think it's for they used to do it. I don't know why. Let's search it up. What do we have to lose? Why in the C in the main we include argc and argv. The first parameter argc argument. It's argument count. So this counts the arguments, indicates how many arguments. The second parameter is an array of pointers to an array of characteristic objects. Okay. Oh, I think like if you execute it, if you compile it, the malware, and then we give it more parameters like A, B, C. The RxC will say us that there are three parameters, and the RxV will include their names like A, B, and C inside the array. Okay. This is a classic variant. We define payload, allocate memory, copy into the new buffer, and then execute. Okay. So this is the new payload. He says it's a 62-bit meow meow. I will call it dog dog because I want messages without encryption. Okay. Again, same things. There's two handles and a pvoid. It says it is a process handle, a remote handle, and a remote buffer. What does that mean? I think the process handle is for a local device, the remote is for a remote device. And I don't know, process handle versus remote handle. Let's see their difference. Process handle is identified and provides control of native processes. Let's see the official Microsoft. When a new process created in a function handle, so a new process primary thread, its primary thread are returned. Identify provides control of native process. Okay. So this will be probably the process that we want to be executed. It will handle it. It will also remotely handle the thread and the buffer. Then it's gonna parse the IDs. It will check the PIDs. Each process has a unique ID. Uh, in Linux there is a command, and also in Windows there is a command. I don't remember any of them. How to see the PID in, let's see in Linux first. I think, yeah, it's psox. And in Windows it is command task list. Task list. This gives us all the tasks that are currently running in our device, and we can see their PIDs like 0, 4, etc. etc. Um, what else? Then again, it will open the process. It will allocate the memory for the remote process. It will copy it, and then a new thread will be created to execute it. Probably because as I have said before, threads are inside processes, and you can have multiple threads inside a single process. but not one process inside multiple threads. The main limit with antivirus scanner is the amount of time they can spend on each file. Okay, during a regular system scan, we have to analyze. Okay, yeah, that's the main problem with antiviruses. Because if you just go to the normal antivirus, I have disabled everything, and you just do a regular scan, it will scan through a ton of files. So it needs to have a smart way of actually understanding if it's malware or not. During, yeah, it cannot spend too much time on a single process. Come on. Or on a particular, one of the classic AV evasion trick besides payload encryption. We just allocate and fill 100 megabytes of memory. Okay, so we just use a little, only like a few. Oh, okay. So this probably to delay it, to show like the first 100 megabytes are like nothing, and after the 100 megabytes they're gonna be the actual payload, and because the antivirus cannot spend too much time on it, it will see the first 100, say, oh yeah, there is nothing in here, and will move on. That's my logic. I don't know if that's what's gonna happen. So he gets a null pointer. He mallocs 100 megabytes. Malloc uses the heap, not the stack, to allocate memory dynamically. And if the memory is not null, it will set the memory from 00 to 100 megabytes. Let's see exactly what it does. Memset. Let's see the three variable, the three past variables. I don't know how to tell them. Three values. Okay, the first is a pointer, the second is value, and lastly is the size. So points to a block of memory to fill. So this points to the memory, which we said. Value to be set. We want it to be 00. The value is passed as an int. Okay, and the number of bytes to be set to the value. So 100 megabyte of zeros. So there's actually gonna be like a bunch of zeros that will fill it just for the antivirus to not spend too much time. So let's go update our simple malware, the favorite Cockmelon C creator. So yeah, this is the exact same. This is the exact same. We changed here. Let's close this. Let's put this on the left and this on the right. And let's do the changes ourselves. So the DW word, why is there only a space? DW word PID, which again is the process ID. Then the PID is gonna be set to atoy argv1. I don't know what atoy is, so let's see. What is atoy? A function that converts a string, okay. The atoy function defined in the header is used to parse a string and return the integer equivalent. What? Oh, okay. So this is like the ORD, but the reverse in C. The Python, the ORD will convert a number um, to the ASCII, and the atoy just does this in the opposite way, but in C. It gets the ASCII value and it gives it an integer, if I understand correctly. String is converted as, yeah. Okay, so an example, string converted to integer. The string is this. Atoy, it converts it, and input strings to be converted. Why is it the exact same thing? The string is converted. Where is this number? Okay. it gets us this, converts it using a toy. Okay. Still don't understand why that it works that way. No, that's right. Okay, it just converts a string to an integer. Okay, so for example, if it was this, it will return 0 because there are no numbers, and if it was like this, it would just give it to us in the integer form. Okay, if it was a mix, I think it would just uh, print there are if there are two things that come to mind. If it's like this 10, this and 10, it would either return 0 or it would return 10 10. I don't know. Okay, then we do allocate the 100 megabytes of memory. So char, same logic before, we initialize it to null, then memory gets the car pointer and allocates memory. Let's just copy this and paste it here. Don't want to count. If the memory is not a null, so there is something inside it, we set the memory to 00 this many times, 100 megabytes of times. I have forgot to put this here and here. And then it's gonna free it. It's important to free the memory, and it's our responsibility in C. Then this is the same, so we will just add this. No, it's still okay. Oh, we don't close it. Everything is gonna be inside. Every single thing of this is gonna be inside the the if statement. Um, okay. And if it's null, what's gonna return? Okay, sure. I guess he knows better. Let's clear it. What we did here is as before, as in here, we initialize the memory to null, then we allocated the memory, then we initialized 100 megabytes of zeros, and then we just execute the normal payload. Where's my payload? It's here. And let's now GCC the malware v3 show malware v3.exe -m console -i /user. Oh, I need to find the folder. Why? I think it is included. I think I have done I have included this as a what's called as a environmental variable. I will see if it's needed. These are like permissions. And we do have a malware ver3. Let's try to execute it. Ver3. And it will open. Let's do it in the notepad for now. It just opens it up. Okay. So this just necessarily opens itself up. It's just a message board, message box. And if we run it, we should get a meow meow. Where's the meow meow? There is no meow meow. payload did not work. Let's try again. Malware v3. Please have a meow meow. I will also try it in PowerShell. Can't I just run it? No. Okay, let's try in here. Let's search for PowerShell. What if you do? Let's go to desktop. Let's go to testing. And let's execute the meow meow. Why? Why is it Visual Studio? It just opens my code back to me. Yeah, it did not. Where's the meow meow? She just does what? I'm writing a victim machine. Yeah, I tried. Maybe this should be also added. Let's just write, I guess. Let's go here. Add this. Okay, let's try the meow meow again. Again. Frick. Why? Okay, let's give it a different name. Just in the case that's the problem, but I don't think. Let's do v3 v v3 meow. Let's execute malware v3 meow. PID 0. Okay, so this did actually play a part. Um, but let's actually search for mine in here. This include. Okay, let's just do it like that. Let's see. Will this work? Place your bets. Okay, it deleted it. So let's add the backslash I first. The minus I backslash of okay backslash. So let's change everything backslash backslash and backslash. No? Yeah, okay, there is. Will this work? Again, place your bets. No. Great. Why? No idea. Well, he essentially just does this. So let's try to explain the code and leave this thing, this meow. So essentially, this is the payload for the message box, which for some reason does not work. Let's move on from that. Then it initializes some two handles, one for the process and one for the remote thread, and lastly a buffer. Then we initialize a PID for this. After that, we initialize the memory, the pointer to memory, and then we give it its value a 100 megabyte memory allocation, and if it's not now, um, I don't think it should be now. I want to try to print it. So let's printf printf mem. Uh, what should it be? Let's see. It's gonna be char so C and the mem. Oh yeah, I forgot the yes. Let's execute it. The malware meow meow. With meow. Okay, so this is not no. I don't know how to actually show it, but if I did the pointer, it will probably give me an error. No, it did not. It just gave me a bunch of nothing. Okay, that's fine. So this just gives us the memory and allocates it. If it's not null, it will probably not be null unless the memory could not be allocated. It will set the memory with the memory and 100 megabyte of zeros, and then it will free it. Free the memory, the malloc. This will be still be set. So the first will still be. Let's open the p bar actually to see if we can see it. We'll probably be able to see it, but let's do that. Let's go here. Let's go to text, data. Okay, so in the data we see a bunch of zeros. This is like gonna be this is 100, probably 100 megabytes of zeros. I might be wrong. A data, where is it? If somewhere there should be 100 zeros, 100 megabytes of zeros. Let's say in imports, do we see anything? Kernel, close handle, create remote thread. The create remote thread is probably here. Yeah, it's here. We print the PID as we said before. It opens the process and gives it all access. Let's see what the open process actually gets. So open process, not processing process. So it gets a desired access, an shared handle, and a process ID. So it gets the access, the desired access. We wanted to give it all access. Inherit handle, it will not inherit anything. And it will, in the process ID, it will just get the first parameter, which is the 0 as we seen. In the case of this guy, it's not 0, it is, what was it? 3212. And then after that, we allocate the memory buffer with virtual EX. I don't know the difference between EX and the regular memory alloc. Reserve, commit, or change the state of original memory within the virtual address. Okay, So this is just separate space where there is the only difference is that it is a process. It also gets a process, the pH, the process handle, and all the rest are the same as the regular virtual alloc. Um, then remote p. Oh, that's why it's a p void because it gives out LP void. Why is it not an LP void though? It is either he did a mistake or he. What is a p void? Void pointer, and an LP is a long. It's a pointer to any type. Okay, so this is to a zero, nothing pointer, and on the other hand, the LP pointers to anything. Then the write process memory will write the process in memory, writes the data to an area of memory specified process, and it gets the process again, which is of course going to be the pH. It is initialized in this process. Then it gets the base address. The base address is where the virtual location is started, is actually initialized. Then we're gonna pass it the payload which we wanna be copied, the buffer. Then its size, so it's gonna be the size of the payload, and lastly, the number of bytes written. Why is that? A pointer of addresses. Okay, it's optional, so we just give it null to be ignored. And lastly, it's gonna create a remote thread. Let's also open VirusTotal to throw this in. Yeah, confirm. You can scan it. The remote thread creates a thread that runs on a virtual address. So the reason everything this can be this can be executed is because we have opened the process, allocate memory for it, copy the payload, and then actually give it to a thread to be executed. So this just creates a thread and executes it. Executes it. And then it closes it and returns 0 to close the main function. Let's see how many flags. 17, one less. One or no, it's 11 less. We did have 28 before, now we have below 20. So we see that it progressively gets better. Although this is not the same code as before. Before we had something else, now we do have something else entirely. This is without obfuscation. If we actually did obfuscate the payload, it would probably be even less. That's everything. He said 6, but I got 17, so that's fine. Yeah, yes, he said if for better results we can add a payload encryption with key or obfuscation, or combine both of them. And what's next? Malware often uses various methods to fingerprint the environment. They're being executed and perform different actions based on the situation. Okay, for example, oh, there's a lot more. Oh, I was like, is it over yet? Okay, so we can continue. That's great. Where were we? Okay, and what's next? Malware often uses various methods to fingerprint the environment. Okay, for example, we can detect virtualized environment, sandboxes, and analyze virtual machines. Usually can't 100% uh, can 100% accurately emulate actual execution environment. Okay, now this typical user must have a process of at least 2 cores and at least 2 GB of memory. So our model can verify if the environment is subject to these constraints. Okay, so this just checks if this is not like a virtual machine. Usually, if you have like a very small environment, like if you want to simulate a sandbox, you might use like less resources to actually have many sandboxes at the same times, or Essentially, a sandbox is a computer, set computer that you can test malware inside it. So it is like a safe lab environment that you can run malware. And he says like a way to at least understand is check if the resources are bigger than this, than 2 cores, 2 GB of RAM, etc. I would probably say nowadays, if it's less than 8 GB of RAM and if the cores are less than 6, it would be a red flag. But that's just me. Um, Bold check resources, system FIS, memory status X, D word broken num. Okay, you get the system information, you get the number of processes, and if the number of processes is less than 2, you return false, so it does not have the minimum resources. And then it will check also the RAM. It it also divides it 3 times by 1024. And if it's less than 2 GB, it returns false. I think this is done because this is it's gonna be in bytes, so you want this will convert it to megabytes, no kilobytes, megabytes, and gigabytes. So this is the first will convert to kilobytes, then megabytes, and lastly the gigabytes. And if it's less than like 2 GB, it's probably a sandbox. Also, if we invoke, I think we can test it. Um, we can. I mean, in my case, I have more RAM and more processing power, even though I'm in a virtual box, so this is not accurate. But we can try this. Also, we'll invoke virtual alloc x numa. This is an alternative version, yeah, that's meant to be used by a system with more than one physical CPUs. Okay, let's actually search it up. Specified for NUMA mode for the physical memory. Same thing, but it also adds the ND preferred. The ND preferred, the NUMA where the physical memory is used only allocating new via region. Otherwise, okay. So again, he initializes the p virtual alloc NUMA, a pointer to this. He did the exact same thing in a previous tutorial, I think in the second with p virtual alloc. He just had, instead of all of this, he just had this. So he just does the exact same thing. And he does a check on the PC with the memory. So he creates a new my virtual alloc, which is gonna be this structure, and he's gonna give it the proc address and module of the current DLL and the allocate x numa. So instead of calling this directly, he's like using an intermediate method of actually calling it. Then he's gonna use this and to get the current process to the memory with the reserve and commit. Let's see the reserve and commit. What are their differences? The allocates memory changes and reserve a range of the process's virtual addresses. Okay, so this allocates it and then reserves it. Reserves it. And it gives it execute and read and write, read, write, and executable permissions. I think this would raise some flags because in a previous way he did it. He gave only read and write, and then inside here he again changed it. But if he does it, I think it's fine. It's probably fine. Then check if it's not null. If it's not null, it returns false, and or if it's actually null, it will return true. So this will just check if if there is enough allocation. What we're doing here is trying to allocate memory, yeah, and if it fails, it just exits, yeah. So it checks this, and if it does have enough memory, it continues, or else it just closes. Since the code is emulated, do not start it a process with the name binary file. That's where we check that first argument contains name of a file. What is my name? This just sounds like Breaking Bad. What is my name? Heisenberg. Just a meme. Um, Again, str probably string. Str returns a pointer of the first occurrence of string 2 and string 1. Return the argv if it's the hiker, if it's null. If this is correct, then what's my name? WTF, and then a sad space, and then it returns -2 to showcase that it failed. I accidentally went down. Okay. Is it possible to ask the operating system if any debugger is attached? Okay. Many times, if we don't want any security personnel to actually check our code, we'll check for a debugger. If a debugger is present, it will just close it immediately. Dynamic malware, okay, has become the centerpiece of any major. Yeah, at the same time, almost all malware can execute some kind of sample detection logic. Okay. Oh, I forgot. Okay, it checks if, yeah, so just check if this is true. Say we can try to combine all the tricks in the hack to, okay. So let's, is it gonna be in the same? Let's just do it in the same. Let's copy and paste everything and we will explain it again slowly, as always. Go down, 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 and down we go. It's gonna be super similar with before, but there are gonna be differences. So as he said, he broke it into parts. He broke it into a lot of parts. So in the first part, we send the code. He did the virtual lock X and NUMA, which he stated here. He said it's an API call that is an alternative to the virtual lock X, and it's used for more than one CPUs. Then it's gonna check the NUMA again. Again, this is done here. Then we'll do the resource check. If the resources are less than what we want, it will just return false, and we don't want it to be continued. Then again, the payload, same things here. Then it will check the name. If the name is changed, if the argument 0 is null, actually, in this, it's gonna say what's my name and return -2. Then it's gonna check the debugger if there is a present debugger. If there is, we want to be closed. Again, we want to check the NUMA. Check NUMA is here. Yeah, check NUMA. We want to see if it is available, if it is there. That they will fail in antivirus simulators. Let's get the processes. Explain it, but I want to understand it as well, so I might just see it twice or three times. It calls the pointer will be initialized. It will create a new variable where it gets the virtual log x and NUMA like previously with the get proc address, and inside the get module handle from inside the kernel 32 we get this. I'll give it to the pointer, so it's gonna point to this. And then we will give the memory the current process and reserve the memory, commit and reserve. What's next? Then we will check the resources. So we initialize them before above to check them inside here. If it's false, we could say it's possibly a sandbox. Then we allocate and fill 100 megabytes of memory with zeros again. Then we open the process, allocate the memory, write the process, and then create the thread to execute it and close it. Pretty easy, pretty straightforward. It is the previous steps, but again combined. Let's GCC it. We will do the exact same thing. Let's remove the meow meow, delete it, and let's execute this. I hope it's saved. And let's execute v3 meow meow. What's my name? WTF. Okay, in my case, it shows this. It don't think it should be like that. It should be malware v3 meow. exe. Compile it again, test it, and use with the PID 0. This happened because in his case he names it the output of the file is gonna be hacked too, and in my case it's a different name. Um, the first argument meaning is this. As we see, we do not start as we were in virtual machine with one core CPU. Let's go for Aristotle again. Let's do it again together. He does it alone. We do it together, me, myself, and I. Let's check it. Confirm. So as useful for register, we can add encryption and obfuscation, classic, to include this example. So it's pretty simple to bypass antivirus evasion with exploit their weakness. Yeah, okay. It only requires some knowledge on the Windows system and how the antivirus works. That's pretty important. If you don't know how something works, first study it and then try exploiting it. Okay, we get more errors, not errors, we get more flags. That's interesting because he, on the other hand, he got 8 and before he got 6. Okay, so it went above for him and for me as well. I think I had 18 and now it's 20, so it's 2 flags more. It's the same. Also, we can try to detect devices and vendor names in our machine, search VM-specific artifacts, check file, processor, Windows names. Check the screen resolution. Okay, he will show them as well in the future, as he said. And that's everything. Okay, perfect. I hope everyone understood everything. If you have any questions, please let me know. I would love to answer them for you. Please comment, leave a like, subscribe, the classic, and I will see you in the next one.